Okay, good afternoon, everybody. Today, December 7th, as I mentioned earlier, in the first class, we have two professors to teach this course. The first one is me, and the second one is Professor Lai, Robert Yixiong Lai. So let me introduce him again. He graduated. He is an alumni of this university. He graduated 1962, long time ago, in civil engineering. He graduated from this university, 1962, and 1967, he got a master's degree from Northwestern University, also civil engineering. And 1969, he got his PhD degree, also from Northwestern University, civil engineering. What? Yeah, in the United States. Do you know where is this university located?
Evanston, Illinois.
Yeah, Illinois. Yeah, around Chicago. Chicago. Do you know Chicago City? Okay. So after that, he has many experience in SUNY Buffalo, University of Wisconsin Milwaukee, and the Johns Hopkins University, etc. And TRW, and after that, 2003 he came back to Taiwan. Then he was National Applied Research Laboratory chairman of the board from 2006 to 2008, and from 2008 to 2011 he was a chair professor in Datong University. So here's a picture, here's a person. So let's welcome Professor Lai. He's going to give the lecture for this course, for this class. Okay.
Okay. Hi everybody, good afternoon. I'm very pleased to be the guest lecturer of this class today and talk to Professor Shen earlier. Probably next week I'll come here again. In the past 3 years, Professor Shen and I share teaching this class at Taiwan University. When I was still as a chair professor at the Datong University, which is a private university in Taipei. And we share teaching this course mainly to the students from foreign countries. And I just got back from Taiwan, from Maryland. I lived in Maryland for 31 years last weekend. I'm so happy to be here again, Professor Shen. Thank you, and Mei Xu. Nice to see you again. All right. I understand that today we're going to focus on the natural disasters mitigation technologies, mechanism developed in this country. All right. Now, later on in this class, we'll show about 20 minutes of video, which was filmed in about 5 years ago, and was part of the TV programs called Scientific Taiwan. Right? How Taiwan handle or deal with the natural disasters. They are typhoon and earthquake mainly. Of course, the disasters came with typhoon as landslides or mudslides. Right? Now Taiwan, because of its geographic locations, unfortunately, is in the earthquake zone and also in the major path of typhoons. Now, I don't know how many of you know that in the Western Hemisphere, we have similar phenomena, but it's not called typhoon. It's called hurricane. Now, also in the Indian Ocean, a similar phenomenon, neither called typhoon or hurricane, but what? Anybody knows?
Cyclone?
Cyclone. All right. In Indian Ocean. These three, cyclone, hurricanes, and the typhoons, they are the same. Now, normally, there's strong winds come with huge precipitations, rainfalls. Normally, originated from 5 to 10 degrees latitude of the big oceans, like Pacific Oceans or Atlantic Ocean or Indian Ocean. Particularly during summertime, when the surface temperature of the ocean water reaches around 26 degrees centigrade, the evaporation rate increases. So the ocean water will evaporate, becomes moisture, and then moving up. While it's moving up, the temperature of the air drops. When it reaches a point, it condenses, becomes water drop. All right? And then because the air, the atmosphere in that area with huge evaporation rate is very moist, humid. Therefore, the air temperature, the air pressure, or we call it high low pressure. The higher humidity is low air pressure. So you have a low pressure center established, and then suck in the air from nearby with higher pressure, air pressure. So when there's a disturbance, it becomes a vortex. This is atmospheric science, fluid mechanics. All right? How typhoon or hurricane was born. And then in northern hemisphere, this vortex is counterclockwise. In southern hemisphere, it's clockwise because of rotation of the earth. In the meantime, the whole storm is moving clockwise in northern hemisphere and counterclockwise in southern hemisphere. So, for example, in Pacific Ocean, it normally starts from nearby Guam or Hawaii, maybe a little bit west, and then moving westward. When it approaches land, like the Philippines or Taiwan, it change directions. Later on, I have slides to show you that. Every year, averagely speaking, about 8 to 10 typhoons will pass Taiwan or nearby. Today, this year, I think 2011, we have few typhoons. Right? But particularly in year of 2001, now the number of typhoons past Taiwan is more than 12, and it caused tremendous damage. So this is one of the problems of Taiwan. Have to face one of the natural disasters. Now the other one is earthquake. Taiwan geographically located in the place which from tectonics viewpoint is Eurasia plate and the Philippines plate meet. Anyone knows about tectonic, the earth plates? Now, these two plates meet. They push against each other. Not only that, moving the lands upwards to have high mountains. Like in Taiwan, we have many high mountains. Central Mountains, Alisan Mountains. The elevations could be almost 4,000 meters. It's because the two plates press against each other and moving up. As a matter of fact, on the Earth's surface, all the high mountains was caused by the press of two plates. Like in Europe, we have Alps. It's because there are two plates pushed against each other. Like Himalayas, the Indo plates and the Eurasia plates push against each other. You have the Himalaya mountains. Like in South America, we have Andes. Again, same thing. But when these two plates press against each other, always build up the stress. And if there is any disturbance, there's a disturbance, the earthquake generated. Taiwan, unfortunately, is in between Eurasia place and the Philippines place. Now in Japan, earlier this year in March, in the northeast part of Japan, Honshu Island, it was 7 something Richter scale earthquake that induced the tsunami and caused damage of the nuclear power plants. Remember that? Now Taiwan, unfortunately, is the same thing. Because of this, we have to deal with it. So Taiwan developed some kind of mechanisms to reduce the damage when it occurs. So later on in the videos, we'll show you how Taiwan has achieved some kind of success to mitigate the loss due to natural disasters. When I served as the chairman of National Applied Research Laboratories a few years back, under these organizations, research organizations, which the funding was through the government, all the applied research center or under these organizations called National Applied Research Laboratories, which later on in the slides will show you, including the National Space Program, just like in the US called NASA, but much smaller scale. Now we launched 3 satellites. One of it we call Formosa 2, has a remote sensing camera with a resolution just like a Google Earth. It's 2 meters resolutions. It surveys the Earth at a particular point twice a day. So it's very, very effective. Generate a lot of nice images. So we have the National Space Program, also under this National Applied Research Laboratories. And last week, Professor Shen told me that you visit the Earthquake Research Engineering Center right nearby. That's also under National Applied Research Laboratories. And also in Hsinchu Science Park, we have chip implementation center and a narrow. I'm sure, are you going to take them to already visit? Narrow device, which is the manufacturing of semiconductors, is also under these organizations. Besides that, there's a few more. There's National Center for High Computing. The largest computers located in Hsinchu, in that center is also under these organizations. And also we have a centers for natural disasters control or research. Also, altogether, I'll show you later the organizations. So National Applied Research Laboratory was in a position to provide the technical support to the government to handle the natural disasters. In 2007, I was asked by the government, Taiwan government, to present a paper at Honolulu, the Asian Pacific Homeland Security Technology Summit. So we present how Taiwan deal with the natural disasters. Nowadays, Homeland Security is a beautiful name after 9/11. Homeland Security is man-made problems and the natural problems. Man-made mainly is terrorism, but it includes also the natural disasters. So it's part of it. And I think I'll show you the video first, and then later I'll further explain about the matter. We'll touch it. In the video, you'll see that how we set up the 24 hours monitoring systems in the main rivers, reservoirs, and the bridges. To when the typhoons come in, during it hits Taiwan, all the rivers is a dangerous place, and because Taiwan's geological issue is that high mountains and small islands, so all the rivers, the slope is very steep, so the water's running very fast, and the river stage rise very fast. So we have to monitor the water level in each major rivers in case we have to close this bridge or evacuate the residents in the dangerous area. There's a mechanism developed which turned out to be quite effective to mitigate the losses. And in also dealing with the earthquake, the whole island, we had more than 600 seismic sensors placed, each one with GDPs. All right. So when the earthquake occurs, we immediately knows where the epicenter is, and also we know the potential damage, the most damaged area will be. So we can launch our limited resource to there. When earthquake occurs, time is very critical. I don't know whether you heard of the critical time for earthquake rescue is 72 hours. Normally, a person cannot survive or buried after 72 hours. So you have to be there to evacuate. Right? In 72 hours, and we have to launch, concentrate our limited resources to these potential, the most the place need help most. Right? So we have the systems, and it turned out to be quite effective. In 1999, there was a big earthquake occurred in the central part of Taiwan. At that time, 1991, we lost more than 3,000 lives in that big earthquake. So learning from that, we established some kind of mechanisms, so just to reduce the losses. All right. Any question before we show the video? Now, let me add one more point. Last week you visited this earthquake research engineering center. Professor Shen told me that you were pretty lucky. During your visit, they demonstrate a test. That facility is one of the best in the whole world. Not only that we have good facilities to do the research in earthquake, but also the construction technologies in Taiwan is pretty good. As you can see that in Taipei we have building 101. Anyone visit there? Until a couple of years ago was the tallest building in the world, right? Now in Taipei used to be a lake, inland lake, and then later on after it's drained out, so the sediments free out. So here at this location, underneath is all mud. It's very soft. Now to build high buildings on this soft earth is not easy. So we have to piling maybe 20 meters, 30 meters to reach this hard earth or rocks. Then the rest, the weight on that. So the construction technology in this country is pretty good. And also the construction material research is very advanced. And that center you visited last week was the main research center dealing with earthquake or construction. All right. With this, maybe you can show the video. Okay.
强台泰利丰沛的雨量已经让台20线肝肠寸断，桃园乡居民的对外交通也完全中断。
含水量饱和，因此造成了土石坍塌，泥沙石块随着雨水冲刷到路面上，看来触目惊心。
另外，在南投竹山，因为清水溪溪水暴涨，将投149线通往竹山统投的瑞清便桥再度冲毁，滚滚河水四处飞溅。土石流1秒钟可以冲到10公尺远，也可以瞬间冲毁无数家园。家园可以重建，天灾能不能预防？
防灾警戒区域，请勿靠近。
您现在看到的摄影机就是所谓的水情即时影像监视系统。它可以360度旋转，同时还可以24小时监控台湾各大重要河川以及水库目前的水位状况。
那这个有点像是这个私人的 SNG 车，就是说一发现状态的时候，我可以事先看到现场的情况。那因为我事前对现场的情况都有所了解，所以我看到这个照片，我就可以比对说，其他这个没有灾害的时候，没有淹水的时候，它的情况是如何。那这样的平常比对关系呢，可以让我们在紧急的情况之下，在资讯不是很明确的地方之下，我们可以做出比较明确的判断。那比方说这个地方淹水的这个整个量级情况怎么样？这个地方有哪些救灾资源应该进来？
影像即时传输的重要性，就好比如美军作战时，大兵把最前线的状况透过视讯科技立即传回到后方的将领手中，作为指挥作战的重要依据。而这样的观念也可以用在防灾救灾体系上。这里是经济部水利署的防灾救灾指挥中心，墙壁上是全台湾106个影像监测站所传回来的最新水情资料。
当我们现场的一个资讯，把现场的各重点的地区 及时的一个传回来以后，把这些的水位状况，你像盐山子分洪的地区，你它的水位的上升状况，我们随时的掌控了解，大概它的上升的时间多少多少个钟头以后，我们需要泄洪需要分洪，这样盐山子需要分洪，或者是各个点它的堤防地区大概是会达到什么时间会超过它的警戒水位或者是有危险的地方，堤防地区如果说有议题危险的时候，我们会紧急的去按照程序去通知各地方政府，或者是闸门。
这套系统3年前才开始陆续建制完毕，比起以前完全靠人力到灾害现场观察，这套监视系统大大的提升了防灾救灾的能力。
最早完全是靠人力，人去一趟回来到办公室，可能那时候的传输系统不方便，顶多用电话打，甚至地区的话已经水来了就进不去，所以说时间来回要2、3个钟头。受了这些及时的监控的系统，我们可以随时的看到它的水位的变化，可以预先提早在2、3个钟头之前知道我们这一个水位地区它的水情上升的状况是不是会有议题的一个危险。
这套系统能够顺利运作，背后有一个重要推手，就是国家高速网络与计算中心。国网中心先进的电脑主机提供高效能的计算以及资料库的储存能力，让防灾体系如虎添翼。
那我们国网中心提供的是一个平台，那诚如所说的我们把影像收进来，这是一个平台的一个处理。再来，你对这个事件的处理，它需要另外一个平台的一个事件的处理。那我们把影像拉进来之后，我们可以看到一个面的附近的一个淹水的一个情况，告诉他们说现在的危急的程度到怎么样，或者说已经淹到什么样的程度，能够让这个下游的居民能够知道上游的一些情况的时候，那他对于这个灾害应变的这个感受力就会更好。这样子，
透过国网中心的一个计算网格的一个平台，洪水演算的一个模式，我们就可以提前预估到未来几个钟头以后这个下游的一个水情状况因此可以争取到几个钟头的一个应变的一个时间。
几个小时的预警就足以启动通报系统，做好防灾救灾的工作。
为了大家的安全目前先到福德国小支援
迄个水到一定的警戒线，就是讲到咱这个桥已经要挖桥面啊，咱派出所一定的桥封开就是交通管制完管制了，阮是上基层的阮就是爱甲这村民广播叫伊讲咱桥已经封开咱有危急住户伊的安全咱就是爱疏散，爱来庙宇活动中心因为水已经太悬了安尼啊。
为了健全整个防灾体系，国家实验研究院甚至邀请了美国普渡大学的商文义教授以及佛罗里达大学的叶高次教授，准备成立台洪中心，从气象以及水文的基础科学开始做起，为台湾未来的防洪减灾做第一线的把关工作。
我是希望讲会当整合讲国内加国外的这科学家，还是讲这学者大家共同来发展一套的台湾的模式啦若有迄个模式的是，咱就会当做更较好的预报就是讲包括讲风台，还是大水还是这个土石流各方面的预报，咱会当做较绝对无可能做到 perfect 的啦就是讲这无可能讲一个完美的但是讲说咱会当讲做比希望会当做比以前较好
气象以及水文的模型建立好之后，不然只要输入相关资料，就可以评估出台风或土石流可能造成的灾害情形。
这个要做真多的哦，其中魔术的研发啦吼，过去才我知影吼，咱拢是用外国的魔术啦吼。咱若咧做，你就知影，做魔术的人拢真清楚吼，你用魔术拢会发生问题。咱若引用外国的魔术，咱无法度解决这个发生的问题，所以就反正是讲哦，创调不定来哦。咱若家己有研发的魔术，咱会当代代相传。魔术是干那破坏的，你讲淹水情况，最主要是咧算流速参水深。哦，每一个看都有咯。你若讲要做多一区，任何一个区域，最主要是预测也水深参流速了。
家园可以天灾可以预防，科技日新月异，人类的生命安全也将更有保障。情节总是不停想象人类可能遭遇到的浩劫，而现实生活中，这些悲剧也确实不断在各地上演。2003年12月，伊朗发生瑞士规模6.3的强震，3万人丧生。2004年8月，中国云南发生规模5.6的大地震，12万人无家可归。11月，日本接连3起强震，造成上千亿日元的损失。12月，印尼9.0强震，随后引发的海啸，保守估计有20万人失去生命。2005年10月，南亚规模7.6强震，光是巴基斯坦这个国家，死亡人数就高达2万人。设立一套精准的地震预警系统，避免悲剧一再发生，是全世界科学家努力的目标。这里是国家地震工程研究中心，您现在看到的是3轴地震模拟震动台，它可以上下、前后、左右摆动。历史上所有曾经发生过的地震，都可以在这里重新模拟。
那基本上呢，在这个世界上发生的那个重要的那个地震啊，都基本上可以在这边重现啊。那我们就是把这个地震重现呢，然后看说它的那个结构的那个行为是怎么样。那比如说现在目前在做的话，就是说在一个这个普通的那个钢的结构，然后里面加了一些什么那个消能的气，然后呢让它的那个振动量啊能够这个递减。那振动量递减的话，那么它的那个耐震能力呢就可以提升了这样。
启动地震防灾系统，气象局地震测报中心设置的强地动观测站是系统的最前线。位在一个小角落、外形相当简单的设备，这就是所谓的地震观测站。千万别小看它，里头配备有最新的科学仪器，包括感应器以及卫星定位仪，24小时随时掌控所有资讯，成为地震防灾体系的先锋部队。
我们在每个车站都会装设这种简易型的 GPS 卫星定位器，好，这主要是提供强震站它里面的一个地理资讯的位置，还包含时间。那这强震仪主要的过程就是3个方向的一个感震器，那感震器大概的形状就是大概是这样，大概像拳头大小这样子。那它可以测量3个方向，因为我们在地震观测的话，我们需要得到上下动的一个震动，还有南北向的一个动，还有东西向的一个震动。
从民国81年开始执行的强地动观测计划，目前已经在全台湾设立了686个观测站。以世界第一高楼101而言，里头就配备有10套地震观测点，严密监控大楼内部的状况。
那这个计划里面有一个叫自由场的一个观测。那自由场的观测，我们那时候律定了一个原则，就是说，台湾地区的9大都会区，因为这些人口密集，它很迫切需要这些强震的资料做一些参考。那另外就是说，在我们所知的一些活动断层的附近， 人之类的哈，我们旁边会设比较密集的一个强震站。那另外就像电厂。核市场啦，这些核1、核2、核3，这些重要的一个设施，还有水库，还有军事设施，这些都蛮重要的，所以我们会在这边选适当的地点。
一旦发生地震，观测站的资讯会立即传回气象局的地震测报中心。
地震发生在岛内或是近海的一个区域的话，它平均可以在1分钟内得到一个地震的一个讯息，然后。如果得到这个讯息以后，我们的值班同仁就会根据这个讯息来做判断，来很快速，大概平均在3到5分钟之内就对外发布一个地震的一个报告，通知国人说地震发生了一些它地震的一些消息是这样。
地震发生后，要进行救灾的第一步，就必须进行灾害损失评估，才能正确判断需要派出多少救护人员。投入多少救援物资？
当地震一发生的时候呢，那我们因为事先呢就已经模拟好很多不同的模拟地震的结果，那我们这边开发张力高系统呢，就可以在这个已经模拟好的这个资料库里头呢去查询。那这个查询的这个时间呢，大概20-30秒之内就可以查询到这个损失评估的结果。那评估的结果大概包括人员伤亡啦，或者是建筑物倒坏的数量啊等等这一些的。那这个应变的人员，他就可以第一时间收到这个讯息，就说，这个地震呢，可不可能，或者说会有多少的这个危险的这个，就是说灾害产生这样子。
启动震灾损失评估机制，就得启动庞大的资料库，而这就多亏了国家高速网络及计算中心的运作。
那未来的话，应该会有这个所谓的他们的防灾的通报的这样的系统。那这样的系统的话，他们要传送的这个资料量势必会非常大，有一些相关的地层的这个剖面图，或者是断层图，或者说相关的灾害预测的范围的资料，大概是在哪边？如果能够让村里长能够了解更清楚的话，事实上对他们整个疏散的能量，相信会比较会更强大。
地震防灾系统一旦启动，负责救灾的消防署以及核能电厂、大众运输系统等等，都会在第一时间收到通知，进行紧急应变措施。
我们对一些比较重大的交通设施啊，或是电厂，其实都有一个即时连线的一个功能在这边，就是说我们地震发生以后，会立即透过一些专线的方式把讯息传输给台湾铁路公司啊，或是台北捷运公司、核能发电厂。或是一些比较重大的消防单位、防灾单位，其实都有及时的连线，来通知他们做一些应变的措施。
台北捷运系统的紧急处理措施，原则上在2级以上到3级之间的地震，我们会让列车全部都先停止下来；在4级以下，我们一样会把列车在我们的车站站间。那如果没有灾情回报，这个时候我们就会让列车以5公里的方式速度把列车开进车站。那如果到5级，那5级因为它比较严重，同样的我们会立即停车，在平面跟地下车站呢还是一样可以让5公里的方式进入车站，但是在高架段，因为它是属于高架的结构，我们有比较谨慎的方法，就是让列车还是停在原地。那我们会请车站的同仁用步行的方式进入车站，进入那个列车，到那个列车的地方，确认他所要行走的这一个路段是安全，没有任何的结构上的问题的时候，才让列车以5公里方式再进入车站。
大众运输系统针对地震研拟了一套紧急应变措施，但是民众更关心的，恐怕是自己的住家或是办公大楼这些建筑物到底够不够坚固。
在传统上面来讲，以往我们都是采用这个弱柱强梁的设计，就是我们的梁呢，这个承载能力比较好。那么后来呢，大家发觉呢，这个柱子太弱的时候，做了所谓的那个 pancake failure， 就是说你的柱子就断掉了，然后整个楼板就压下来，所以你人连逃生的空间都没有。所以后来才会变成是一个强柱弱梁的设计，就是说柱子绝对不能够坏，可是梁呢或许会坏，但是可以帮我们来争取一点逃生的空间。
当地震预警系统还不能像气象预报可以提前好几天发布，那么研发耐震建材以求自保， 似乎也是防灾重要的一环。越来越多国内外的科学家致力于防震耐震建材的研发，不管是斜张桥的设计，还是纤维加进混凝土里，让它少许变形，但是不会断裂。耐震建材的研发，让人类的生命安全多了一层保护。
ここではそのコンクリートの脆さを鉄のような粘り強い性質に変えられないかなと。
而台湾的地震工程在世界具有重要地位。
像萨尔瓦多啊、中南美洲还有东南亚的这些国家，他们会派员呢来上这个所谓的国际耐震训练班的课程，算是一种技术的推广。好，那么来的国家呢很多哈，甚至也有比较先进的国家，像新加坡也派人来了，就吸引了很多国际的友人哈，他们也是在做类似的实验研究的，他们会来学习。
要完全避免天灾人祸，似乎不太可能。人类唯一可以做的，就是建立一套完善的预警系统。当我们研发更好的耐震建材，建立更好的应变措施，设立更精准的观测仪器，那么下一个921，我们才能更勇敢面对。
Okay. Before I show you a few view graphs, any question about the video? Any question? Now in the videos, microphone. You see that we placed about 700 seismic sensors all over the islands, okay? Particularly focus on high buildings like 101, building 101. We have a dozen of the sensors there to measure earthquake intensities, and also near the nuclear power plant, and the reservoirs and the breaches, etc. All right, and also you see this flood monitoring device placed more than 100 all over the islands. So collect all the informations, the water level particularly, and send to the high-speed computing centers in Hsinchu, the huge computers, and with the forecast, the models of each rivers, main rivers, with that kind of precipitations, all right, and then we predict that how fast the water level in the river will rise, and also the speed of the water, so we can tell that where the residents should be evacuated. So in general, that we in these islands set up this kind of infrastructures, mechanisms to provide the technical support to the government. That the officers, the political officers, normally is the Deputy Prime Minister. Deputy Prime Ministers, when there's a typhoon, earthquake, the person has to go to the evacuation, the command centers nearby here in Xindian. The person has to station there 24 hours a day. And he or she will make a decision whether to evacuate or not, or send the rescue teams to a specific locations. Now, any questions before I start the view graphs? Now, the following few view graphs prepared by Professor Shen and I several years ago I'll show you that about the organizations of National Applied Research Laboratories. National Applied Research Laboratories. For those of you who are interested in knowing more about this, you can get on the website, narl.org.tw. Right? And then we'll say that Homeland Security technology developed at NARL, the Taiwan Earthquake Loss Estimation System, we call it TDIS, and the flood mitigation grid. We develop grid systems and decision-making systems for early warning. This I'm going to quickly go through because it's kind of tedious. Then we have 3G's GIS, Taiwan Platform for Natural Disasters. GIS is the worldwide geographic information systems. Taiwan is an important member of that. The whole islands, we have very, very good information about geographic, GIS. For example, in each city, each village, what kind of buildings, how many residents there. What kind of buildings means that kind of specific buildings can sustain how big the earthquake. We have whole islands informations centralized at the earthquake research centers. And we developed TILIS systems. So immediately when the big earthquake occurs, within a few seconds, the director of the earthquake research centers immediately knows that where could be a dangerous place. And the director will submit this to the command centers for the decision makers to make decisions. And then the management support, etc. All right, this is the regular the organizations of National Applied Research Laboratories. Okay, the chairman of the board and then the president. All right, under these organizations, we have now 11 research centers. As you can see, that National Narrow, you visited there in Hsinchu, Narrow Revise, which is the manufacturing technology technique of semiconductors. Natural laboratories or animal centers, which we produced more than 250,000 different kinds of mice for medical research purpose. And then the National Center for Research of Earthquake Engineering, you visited there last week. Then Instrument Technology Research Center, which is not particularly directly related to natural disasters. But also we have National Center for Disaster Reductions, Science and Technology Reduction Center, National Space Organization's Chip Implementation Center, which is the IC design, National Center for High Performance Computing, as I mentioned, and also Policy Research, Technology Policy Research and Information Center, and most recently we have Ocean Research Centers. This is already established in 2009. And also in planning is Typhoon Flood Research Centers. So, as you see that in the video also, that you can see that when it comes, we have to deal with it. Now, here's a summary of part of the summary of some typhoons. Now, for example, in 2001, we have 8 major typhoons attacked Taiwan. 2004, 6 major typhoons, and 2005 is 3 Category 4 typhoons hit Taiwan. This is a summary. You see that this 201 Ochebi, Trajon, Nari typhoon, 201, which caused big damage, particularly to city of Taipei. And this damage includes some man-made. All right. You can see these 5 typhoons hit Taiwan are all in 2001, and you can see that the death of number of lives lost, injured, and economical losses, etc. You can see that quite huge. All right. Now, this is quite interesting. It's messy, right? Each lines represents one typhoon. One typhoon. Now this Taiwan is here, and the Philippines there. Between 1980 and 2005, 25 years span. How many typhoons affected Taiwan? You can see. So Taiwan is unfortunately located at the traffic jam place. And you see that, as I mentioned earlier, that the typhoon normally happens somewhere in the Western Pacific Ocean, here. And then moving to the west. And when it reaches the Asia or the island chain, it changes the land, it moving clockwise here. Right? So it's always clockwise in the northern hemisphere, but the vortex is counterclockwise. But in the southern hemisphere, particularly in cyclone, in Indian Ocean, it's just opposite. Right? So you can see that typhoons always happen between May and October, particularly August and September. That's any question on this? So when it happens, when it comes, causes a lot of inconvenience and damages. Now, debris flows and mudslides, etc. Okay. Now, as I mentioned, that National Applied Research Laboratories has right now we have 10 research centers. Many of the centers are involved in the mitigations of natural disasters, like the remote sensing satellites launched by the National Space Program Office, and the instrumentation. This is computing center and ocean research, forecast, predict whether the typhoon will be formed or not. All right. And also the National Computing Center has developed a great technology for the forecast. All right. And also here's earthquake engineering, typhoon research, etc. So all these research centers involved to certain degrees develop the technologies to reduce the damage. This is the grid system, national grid system at the High Performance Computing Center. Now, this program we call KIN is Knowledge Innovation National Grid. Right? And here this system is quite big. We have backbone is 40 gigabytes per second. Right? So the whole islands is all under fiber optic or broadband. Right? So the speed is very, very fast. Now, in the high-speed computing center, the grid technology, they developed ecological grid, which we'll talk about this next week. All right, and the flood mitigation grid, medical grid. Have we medical grid? We talked about this before. Well, anyway, also have like for example, several years in 2003, when the SARS attacked Taiwan, we developed this medical grid to reduce the number of people. Also asthma grid, etc. There's a grid technology developed which has something to do with flood mitigation and also earthquake. Okay. And here, as I mentioned earlier, the Earthquake Research Engineering developed a TILIS system to assist the central and the local government for their disaster assessment and rescue planning. Now, in each village in Taiwan, what kind of buildings? The reinforced concrete or others? And which can sustain what degree of earthquake is all in the systems. TILIS has been installed in Central Disasters Prevention and Preparations Council for their implementation. As I say, that this is the command center for the Deputy Prime Minister to make decisions. And we call this TILIS systems. In case of earthquake, TILIS will be automatically triggered to provide a preliminary assessment for command center within 20 seconds. Time is very critical as far as earthquake disasters is concerned. So the assessment report will be sent via cellular phones within 20 seconds right after earthquake occurred. So it's very fast. So this is the monitoring system, as I say, that there are more than 176 sites with 120 sensors in place, installed on major highway, bridges, reservoirs, power plants, etc. This is 3Ds with satellites, okay, image. I will skip this because this is kind of tedious, okay? Now, this is the part of the major results of the systems, particularly. Now, for example, in 2001, Parazi's typhoon, we have maximum hours of rainfall, 147 millimeters per hour, and accumulated rainfall is 757 millimeters. I hope that for those from US, you know how to convert this into inches. 1 inch equals to 25.4 millimeters. Now, landslides and the debris flow occurs more than 673, and the seas of the casualties. In 2001, the Taozi typhoon comes with the human loss is 214. The accumulated rainfall is this. Now, after the systems, this before the system was just installed. Now, the Nari typhoon comes. The accumulated rainfall is more than about 1.5 meters, almost 5 feet of rainfall. And the landslides and the debris flow occurs 475. And the number of evacuations is 24,000, and the casualty was 104. Then in 2004, we have Mandalay typhoons. The accumulated rainfall is more than 2 meters. higher than this. And then the number of people evacuated is reduced to 9,500. Now, casualty is 41, etc. Now, until 2005, when this systems were installed, when this typhoon comes, 776 millimeters of accumulated rainfall, the casualty reduced to 2. Now, number of people need to be evacuated reduced to less than 1,000. It costs to evacuate residents. Okay, so with this slide, it demonstrates that this system is quite effective. Any question on this? Well, okay, I will stop here. Yeah. The last.
Haven't we talking about the last row? What was it, 2008?
The previous one?
Yes, previous slide.
This one? This one? Yes. What, pardon?
The red letters under the red line, what does it mean?
Oh. This one, that is, this system was installed. Okay? And then this was, right, we only count now. This one was now 2005, okay? Now 2008. 2008. Sinlac typhoon comes. Although the system was still working, however, the casualty unfortunately increased to 22. Are you questioning this?
But you don't have data for maximum hourly rainfall and landslide decrease.
Yeah, that was, we don't know. The question is, in 2008, I left that organizations, NARL organizations, so I didn't know. We didn't have the data for this. But we do have the data. As the accumulated rainfall is 1.6 meters. Now, unfortunately, the casualty is 22. It reduces now from 214 to 2, but this one increased to 22. Although the system is still installed, my recollection is this casualty was caused by man-made mistake.
You skipped this line, so I asked.
Pardon?
You skipped this line, so I asked.
Oh, yeah, good. I'm glad you asked this. That remind me. You know why increase? I mentioned, I say that this is a man-made mistake. I remember that. In central Taiwan, there was a bridge, 大甲溪. Now, when the water level rises very fast, we have the monitoring system. Okay? The monitoring system provide the information to the command center. Say, we are in danger. This bridge was in danger. So the command center made the decision, close the bridge. No car, no automobile can pass. You know what happened? The stupid guys only closed one end. The other end still open. So the car still coming. All right? And then bridge failed. That time was a big news. So that's man-made mistake. Not supposed to do this. That's why the casualty increases to 22. So although you have relatively effective mechanisms to reduce the loss, but can avoid the human mistakes. I'm glad you asked this. Did I answer your question? Okay. So the system, this system was installed here, and then it works, right? But here in 2008 September, unfortunately, Sinrak, and tough luck. Right. Any other question? Now, let me summarize this. Taiwan, in a way, is a very advanced societies in the world. It's the high-tech, particularly the high-tech industry. Right? And we developed good mechanisms and technologies to deal with natural disasters, mainly typhoon and its induced mudslides, etc., floodings, and earthquake. Right? We thought we had to deal with them, and I think the system developed, technology developed pretty good so far, but cannot avoid man-made mistakes. Right. Okay? With that, so I'll see. So,
yeah, let me ask you one question. Did you feel earthquake 2 days ago, Monday, around 6:13? Did you feel? Yeah. No?
I feel nothing.
You feel nothing? Yeah, 2 days ago, there was when I sit on a couch, then I feel there was an earthquake 2 days ago. The magnitude about in Yilan, eastern Taiwan, about 5 or 6. In Taipei, I think magnitude 3. Did anybody feel earthquake? No? Okay, good. Because it's very short time, only 1 second. Not like in last week, the movie we watched in Earthquake Engineering Center. The 12 years ago, the earthquake in Taiwan, the Taipei moved each time more than 1 minute. The building shaking 12 years ago. And also, let me ask another question. How many typhoons attacked Taiwan this year? How many typhoons attacked Taiwan this year? Since last July. Anyone? Did you attack Taiwan? How many?
Depends if you include the typhoon on the water or just the typhoon on the land, right?
Yeah, landed. How many typhoons landed Taiwan?
0.
Yeah, 0. in the slide, how many, in average, how many typhoon attack Taiwan during the past 20 years, 10 or 20 years? A lot. What's the number?
3.6.
Yeah, very good. 3.6 each year. Yeah, so this year we are very lucky not to have any typhoon. But did you notice in Thailand, flooding, right? Too much raining, and in Bangkok, the capital of Thailand, they have a flooding. I think 2 or 3 weeks, the whole city full of water. But this year, I believe next year we are going to have 7 typhoon next year because this year we don't have anyone. Okay, any question concerning today's topic? No? Do you have any question to ask them? Ask a question first. Yeah, maybe a TA will ask you several questions. And now it's a TA's time.
In which year there's a heavy earthquake happened in Taiwan in September 21st? Yeah, in 1999. And what is the Richter scale about the earthquake happened? The scale, the earthquake scale, the magnitude or intensity. Is there anyone know? The earthquake scale. The Richter scale. Richter scale about the earthquake. Do you know how Richter scale about the earthquake happened in September 21st, 1999?
What was the scale of the earthquake?
Scale.
The magnitude.
Magnitude. No, nice. Oh, it's terrible.
6.7. 6.3.
No. 8.3? No.
7.4.
Very close. Not very No.
6.9.
Maybe a little stronger, maybe.
7.3.
Yeah, it's 7.3. Yeah. So, isn't there anyone know why there's so many earthquakes in Taiwan? You know why? The reason?
Because Taiwan's plate is moving towards because Taiwan's moving 1.2 centimeters a year today.
You mean
So plates are
plate?
Yeah, the tectonic plate.
Yeah. And
Tectonic plate moving.
yeah, the plate push each other, right?
There's a line and 2 tectonic plates are.
Yeah. So do you know which 2 plates?
In the name.
The name. Yeah, Philippines and Eurasia is right. And beside, it's the Eurasia and the Philippine plate, the 2 plates, and maybe hit or push to each other, so they produce so many mountains or even earthquake in Taiwan.
Okay, let me add this just for your information. The 2 plates moving toward each other. Actually, Taiwan, the whole island, relative to the mainland, is tilted. The southern part of Taiwan is moving closer to Asia mainland. and the northern part is moving away. It's clockwise rotating, very, very slowly. Right? So maybe million years later, the southern tip of Taiwan maybe is connected to Asia mainland. It's rotating. Just for your information.
And do you know there's another nature disaster? It's very often happen in Taiwan. Yeah, it's typhoon. So, what season or which month is it occur very often? Which season or the month it occurs special in some seasons?
July to October.
No, it's yes, July to maybe October, I think. July. And how do the typhoon form? Is there anyone how they develop?
It's a low pressure area which is caused by warm water and cold air.
Yeah, it's maybe called a tropical cyclone produced, especially in the Pacific, northwestern Pacific, I think.
Thank you. Okay, Professor Lai says I show this diagram earlier. Each line represents one typhoon, the trajectory. Maybe originated from Hawaii, somewhere around here, Hawaii. Then come maybe this way, then go to west and north, maybe to Japan or to Korea. So, and this year, last few months, many typhoon attack Philippines. Yeah, many. But none attack Taiwan. Some approach maybe to mainland China or to Japan. So where is Singapore? Where is Singapore? Can you come out and show everybody Singapore?
Here.
Yeah, right here. Yeah. No. I think here. Yeah, somewhere around here. Here is in Indonesia, and here is Malaysia. So between Malaysia and Indonesia, so I think somewhere around here. This is a channel. So Malacca. Malacca channel. Malacca Strait. So Singapore is around here. Anybody visit Singapore before? You too. You? Okay. So how is the weather in Singapore? Rains every day. What's the temperature? Yeah, very warm and hot, between 25 to 30, and raining every day, maybe noon time, maybe 1 hour, 30 minutes raining. No typhoon. So in Singapore, there is no typhoon and no earthquake. It's a very, they are very lucky. They don't have typhoon, and also in Hawaii also, because typhoon originate from somewhere around Hawaii, but move west. So in Hawaii, no typhoon at all. And also in Singapore, no typhoon, no earthquake. It's a very good place. But so besides of typhoon and earthquake. What else? Natural disaster. Can you tell? Hurricane. Hurricane just like a typhoon.
Not hurricane, I mean a tornado.
Tornado. Oh, okay. Tornado, but it's a much smaller scale. Small scale. Not like in compared to a hurricane or typhoon. It's quite big. Much bigger scale. What else? Tsunami. Actually, tsunami originates from earthquake or something else. Tsunami also come from what? Landslide. It come from also come with typhoon also or heavy raining. Yeah, volcano. Yeah, volcano and earthquake sometimes produce tsunami. Volcano produce earthquake. Earthquake produce tsunami. It's a little bit complicated. What else? What else? Natural disaster. A drought. Sometimes may become a desert or many places. Like in mainland China, somewhere around this desert become bigger and bigger. So actually maybe after maybe 100 years or 1,000 years, maybe this desert, maybe half of China become a desert. Maybe. Okay, so let me show another slide. I show you earlier this semester. So I mentioned we are going to have two tests. One is a midterm test, and another one is a final test. And anyone want to have presentation? Up to 3. Let me show you one sample. Actually, I put 2 files already. I put two files presented by some other student a few years ago. Maybe I show you one more. This one is a very good presentation made by 2 students, Mendes and Bentiste. I think they come from which country? Come from South America, I think. This girl, men's student, is in political science. This is a lady student from biochemical science. And let me show you. They took this course and they want to know. They want discovery. They want to discover what's the reason for the success of Taiwan. And can Taiwan experience be applied to some other country? He come from a third world country. And the second question is, can we call the success of Taiwan as an economical miracle? So they made they have some study. So background, I have already put this file in the website. You can check, and actually another one file also. So he did some study. Says Taiwan experience maybe come from maybe earlier during Japanese occupation. That's before World War II or before 1945, and after that, after 1945. And he also showed some geographic location and what's the GDP earlier, and overall policy, government policy for Taiwan in 1953 and later on 1953 to 1956, 57 to 60. We have every 4 years we have some planning for Taiwan's economical development. So he did some study. Yeah, maybe, and we have some help from United States, but only for 12 years. And the United States, they have some financial support. They gave Taiwan financial support, but it stopped in 1965. And we should pay back with 1% interest rate. So, yeah, maybe you can study this file by yourself. And anyone want to have presentation? Yeah, we have. Oh, okay. Maybe can you give your title and your group name to TA after the class? Yeah. Yeah, maybe you can start. We can start next week, and each group maybe around 10 minutes.
So,
yeah.
Do we have any regulations or something for the title, for the topic?
Anything related to technology. Don't talk about something else like culture or something. Yeah, you can have some comparison between Taiwan and your country. You can do some comparison between Taiwan and like France, or maybe what's the advantage of your country in science and technology, and especially if you go back to your country, what you can do. Maybe for your career, you can what business you can do. Yeah, maybe. Yeah. If you want to work in government, or you want to have your own company, you can bring back some kind of technology back to your country, and have your own business. Just like this one, this presentation compare. He want to have some kind of experience, Taiwan's experience, and he want to maybe after 20 years, you become a minister of in your country, maybe, or high-ranking officer. Yeah, who knows? I have many. I know many friends in my age. They are very high-ranking officer, like a minister or deputy minister. So maybe after 30 years, you are minister in your country. Who knows? So you can compare. You can do some comparison, or do some technology study, or maybe Taiwan, or in your country. You can have, and the other one, talk about Taiwan's LED or LCD industry. 3 students, Alan Chen, Ken Wang, Maggie Wang. These 3 students, they did some study for LCD industry in Taiwan. These 2 files, I put these 2 files in the website. So don't prepare too many slides. Yeah, you have only 10 minutes. So I think the number of the slide maybe 10 to 12. Yeah, because each one you need 1 minute to do some explanation. So I think that the number of slides maybe between 10 to 15. So you get some bonus point. So you get some bonus point if you have presentation. So maybe some other student can have presentation later. So maybe you guys you can have next. Can you have next week? Okay, good.